Welcome to Research Project 1, Data Summary and Analysis um, for the Enough project. If you looking at this video, you're interested in doing the analysis using the open source programming language R, which presents a host of challenges in terms of how steep the learning curve is for using the program, but it's also a free program. It's also one that's really flexible. For me, I think it's really pretty a neat program for summarizing data. And so, worth trying it, I think, particularly because it's free and open source. All right, so you've opened RStudio. I would work directly from our enough demo R file. You can go ahead and open it up with RStudio. This is assuming that you've downloaded RStudio and R. There's two downloads that you'll have to have done, following some of the instructions that we have on the syllabus. So I've got the R file summarizing what we're going to do. If it's the first time using R, you need to install packages. They're just, specific scripts to help R do the things that you want it to do. I install a variety of packages that I use really frequently, and they're listed right here. With R, when you want to run something, you hit Control and Enter. That's how you run things. Otherwise, you're just entering, so you're just creating a line break. So Control Enter will execute the command. I've already installed these packages, so I'm just going to load them. So I'm going to highlight all of the loading of the packages here on the left. That's highlighted in blue. And I'm going to Control Enter for those. So what we're going to get is, for me, I think I've already loaded them this time, but what you'll get is some information on the console down in this section where my pointer is that tells you that we're loading the programs. All right, so now we need to have our access the data that we want to use. I have stored the enough study demo.sav file, the data file that we're going to use on my desktop. And what you want to do for each of your individual computers is figure out what is the file path for your computer by get working directory. You can see that's my file path down here, C:\users \that and documents. And then from there, I can create the path that will allow me to access the enough study demo. It's going to be on that file path for the working directory on the desktop, and then the specific file, and the rest of this toData.frame is true. All right. Highlight this, Control and Enter. If this works, we'll get some warning message about how they're treating specific string records, but you get a data set with 461 observations. That's the number of participants in our sample, and then 57 variables. 57 variables is a little weird. I think it has something to do with how the R is reading missing variables. And so we don't want to work with a data file with 57 variables. Instead, what we'll do is we'll truncate the data just to the variables that we want to use. So we'll take this data file and transform it. Great thing about R is it'll transform and transpose your data, but it won't affect the original file, which is a useful feature of R. So I'm going to create a custom data set with just the variables of interest. I'm going to call it enough. So I have this code that says I want to create a a matrix of data that includes only these variables. Control Enter. Oh. Control Enter. Got my variables. That's my matrix of variables, and I'm going to call the data from my variables enough. So now we have this data here. You can see what it looks like there. You can even just go down a little bit to the head, take a look at what the enough data looks like, and it gives you a sense of what all the data looks like here. That's looking at the head of the data. Let's see, what else can we do? All right. So from there, I might look at descriptive statistics for our data. Like that's what we need to do is we need to say like what kinds of participants we have in our sample. And so to do that, I'm going to want to change some of the data into numeric instead of categorical variables. So you can change back from a factor, which is a categorical variable, to numeric and back and forth using this code here. And I'm going to do that for each of our demographic variables. Change each of those into a numeric. And now we can describe the data to get mean, standard deviations, and counts. Describe the data gives you for each of our variables. So there's response ID down here, condition, living wages, the pre-measure, the post-measure, age, racial identity, gender, education, income. You have means all for each, standard deviations for each, and then minimum, maximum range. You got estimates of skewness and kurtosis. What you can see from this summary is that our skewness and kurtosis are fine for our pre and post outcome measures. So if you looked at the the SPSS analysis you find here, we're in good shape to run our analyses using assumptions of normality. Another way to look at this is the summary statistic for the enough data. So just a different way to summarize this, but you can see for each item, for each measure, we have means, minimums, and maximums. That's another way to do it. Still another way to do it, looking at frequencies, would be this table value. So for gender in the enough data, you see we have 190 people who are men, 256 who are women, and 3 who say another gender, third gender, non-binary. Four people saying that. You can do this for income. So I just changed it from gender to income. And so you have the 9 categories, and you've got people in the different categories there. And so you got that bimodal distribution of people in the 4th category, which is between 35 and 50,000. And in the 7th category, which is between 100 and 150,000. And you know the categories because you have the code book to reference. You can also look at the table for hold on, race ID. And so we've got white, 242 white people and 208 Black folks in terms of their racial ID. So this gives us a chance to summarize our data. You can also, what's really cool with R is you can also visualize, the frequency of the data relatively easily with the hist, which is a histogram function. Here's their income. You should see this bimodal distribution of income. Here we are. Income on the horizontal, frequencies in each category. And in that 4th category, you've got a hump of about 89. And then the 7 category, you got a hump of 91. You can also histogram for racial ID, and you should get 2 categories at 1 and 2, right? The white folks and the Black folks in our sample. All right. So now we've described the data. We know who our participants are. You enter the means and standard deviations and some of the frequencies into your participant section. You have also means and standard deviations for the pre and post living wage estimates, which go into your measures section. The citation for those measures is the Park et al. Paper we read in the first week. So now let's make some inferences from our data. One of the first inferences we're trying to make is the association between, in particular, income and living wage estimates. Remember in the prior studies, higher income meant people were likely to say that they needed more to live, right? They needed a higher living wage. And so we should see that same relationship in these data. To look at this is a core test statistic. Here is the correlation between income in the enough data and the living wage pre-estimates in the enough data. That's probably the cleanest way to test that association because it's before any experimental manipulation. And then a significance level is 0.05. That's just convention in our field of psychology. And then a pairwise comparison, which means that we're only comparing correlations for cases where we have data for both variables. And then Pearson is the type of correlation that we're looking at. So here is the correlation. What you've got is a correlation of 0.38 and a total sample of 451. And then if the p-value of the correlation, it's a highly significant correlation. So it's less than 0.001. So it's a significant correlation between these variables. You can also look at the correlation with the post living wage estimate, still an assessment of the association with income, but it's not as clean because it's after the manipulation. So could the manipulation affect relationships with income? Maybe. We don't know yet. So we can look at that association, but basically you see the same result, right? A correlation of 0.36 between income and living wage estimates. As people go higher in income, their estimates of a living wage go up. 451 in the sample, and again, it's a highly significant, less than 0.01 correlation. All right. You can also look at pre and post living wage estimates. Let's see. Just to see if people's living wage estimates are reliable across the 2 time points. This should be highly positively correlated, and indeed it is. Here's the correlation 0.88. Remember, correlations go from -1 to +1, highly significant. This is what you would expect from measuring the same thing twice in close proximity. 454 people in the sample, and again, probability value is way less than 0.05. And then you can also look at living wage estimates with age, just to show you that not everything's totally correlated. So here is the correlation with age, -0.04, which is essentially a zero correlation, sample size 451. Probability value is 0.45, so this is not a significant correlation between age. Cool thing about R is you can actually look at scatter plots to look at the associations between different variables. Here is a plot where we're looking at the association between income and living wage estimates pre. And then, like you can see here, we've got labels for the different axes, just to give us a sense of what it looks like. This is a 0.3-ish correlation, what it looks like visually in a scatter plot. This is going to be down here, and you can see this is a positive correlation, right? As people's income goes up, their living wage estimates on average rise. Really cool, flexible thing about R is that you can also look at a scatter plot matrix really quickly. So here is the scatter plot matrix data for the enough data, looking at income, pre and post living wage and age. So you can look at no correlation, positive correlations, and extremely positive correlations, how they look visually. All right, here is the scatter plot matrix. Income's correlation to living wage pre and living wage post, it's a 0.35, 0.36, this correlation here and here, positive correlation. And then we've got living wage pre and living wage post. This is what a 0.88 correlation looks like. And then this is what essentially a zero correlation looks like, a living wage pre and age. All right. So some cool flexible things that R can do to visualize correlations. We have some initial evidence that's supportive of and replicating our previous research that income is related to people's living wage estimates in a positive way. Next, we want to figure out if there are between group differences in how people's reminders of quality of life kinds of expenses impacted their living wage estimates. The first way to test this is a paired sample t-test, right? Comparing pre and post, right? If reminders of expenses that improve quality of life, if any kind of reminder improves living wage estimates, we should see a positive increase from pre to post in people's living wage estimates. So do this as a paired sample t-test. Here's the code for that. We've got the two variables that we're comparing, pre and post. These are paired, and it's a two-sided t-test. All right, here in the statistics, we see an extreme value of t 5.79, degrees of freedom 453, p-value is very small, right? E to the negative 8 means we're moving the decimal very far to the left, so less than 0.001, and then we see this mean difference of 261 here. So a significant difference between pre and post, such that people's living wage estimates are $260 higher a month post the reminders of expenses that improve quality of life. All right, another way to do this is to examine variations in the quality of life expenses, whether or not those different variations change people's estimates of living wage. That's this analysis of variance, one-way analysis of variance. Here's the code for that. The data is enough, conditioned by our post living wage estimates. So this is just a straight between condition difference. Post living wage estimates is a function of the different conditions. We calculate that with this analysis of variance code, and then we report a summary with this second line of code. And what you get is there's two conditions, but the F value is not extreme at all. It's close to 1, and it's not a significant difference between conditions. And then if we want to look further, we can look further at some of the means by creating a linear model that examines the same model analysis, and then we can get an estimate of means by condition. So we do this here, an estimate of means. Here you can see that 3 conditions have essentially equivalent means, indicating not significant differences between the groups. Okay, so it doesn't seem to matter which condition, but people are increasing their living wage estimates after thinking about expenses that improve quality of life. We can also run this analysis all together, like also taking into account both condition variations and pre and post. That's going to be a two-way mixed analysis of variance. We're going to have to restructure the data so the data understands that people have 2 time points if there are enough estimates. What we do is we create a long data set using the gather function, where basically we have time and wages as our 2 variables. So time is going to index if it's pre or post, and then wages are the specific estimates for each person pre and post, right? So it's slightly changing the data, so it's restructured. So we do that. So that creates the long data set. And now you can see it here. Wages, as are people's wage responses down here. And you can see their responses are for pre, and then there'd be a whole nother column, a whole nother grouping of responses post. So that's how the data are structured. Then we create we switch the enough condition back to a factor structure. And now what we're going to do is structure the data so that we're summarizing the data as a function of mean levels, knowing that there are, people with 2 wages pre and post. So we're restructuring enough. We're looking at the long data where we've got time and wages, and we're converting factors as a function of people's response IDs there. And now we can create a visualization of it. There. All of these are allowing us to summarize our data in this way, with grouping by both time and condition. So we're allowing the data to show pre and post, but also the 3 different conditions. And now we can plot it, showing x-axis has time, y-axis has wages. The color is showing the different conditions, and then we've got labels. And then we can see if that works by showing the plot here. Yeah. So now we move all the way over to figure 1. What you've got is estimates of living wage on the y-axis, post condition and precondition. And then we've got quality of life, investing in the future and paying slightly more. What you see here is that the data on the left is slightly higher for post than it is for pre in all 3 conditions, but that the conditions don't significantly vary between them, right? And then we can confirm that by conducting that formal analysis with this ANOVA test. This is the data, DV is wages, within participant estimates are response ID, and then between is condition and time. So our analysis shows no effect of condition, right? The conditions don't vary as a function of their effects. There's no relationship between condition and pre and post, but there is a significant effect of time, right? With a highly extreme F value and a P value that's very small. So overall, that gives us the summary statistics we need to be able to describe our data and describe our differences between means. All right, I hope this was helpful in navigating R. Remember, Control Enter to run code. You are entering the code in the top left-hand corner. You've got console activity in the bottom left corner. You've got any pictures in the bottom right. And then you have information about like what kinds of data restructures that you have in the top right. And all this together allows you to, create summary statistics and analyze your data. Hope that was helpful.